Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 3753. Basically, the Leetcode problem number 3751 that we have seen already in study videos, right? This is in the daily contest, right? So we already seen this Leetcode 3751, and it was a basic and a easy format or easy version of this problem. And this the 3753 is little advanced, right? So let's talk about this one, right? Because the lead code 3751 and 53 are almost same problem statement. Okay. So both ask for the total waviness, right, of all the numbers in the inclusive range. You know the inclusive range, like if we'll take from 10 to 20, it means we have to start from 10 and we'll go till the 20. Means 12, 13, 14, 15, like the 19, 20 that we will get. Okay. It means the waviness is defined the same way with peaks and the valley that we have already talked about, right? So fewer than the 3 digits is equal to 0 means if we will take, let's suppose 4, 8, right? Only 2 digits we have. So we cannot find the peak and valley. It means the waviness less than 3 digits will be 0, correct? And so we will not count for the peak or the valleys. Okay. The real difference is the version, okay, and the difficulty in the solution style that we'll talk about. The very first, let's talk about 3751. In the this problem is called range 1, right? And it's have the advanced version, right? If you solve this problem, then we should solve this problem that we are talking about today. That is the range 2. Okay. So 3751 shows a straightforward simulations a style approach that computes waviness for each numbers where you have given input side of two numbers you have given and you have to find the waviness, right? That is called the range 1. Let's talk about the range 2. Basically, it's harder variant where the efficient solution is provided through the digit DP, you can say that. So this is the problem statement we have. If you see here, you can see, right? Basically, we have given uh, this problem statement and this is the problem statement we have given. I hope you have gone through this one, right? Basically, the problem says that we have given two, let me zoom out a little bit so you will understand. Okay. So the problem says that you are given 2 digits, nums1 and nums2. It is representing an inclusive range of num1 and num2. And the waviness of the number is defined as the total count of its peak and the value. So what is a peak? A digit is peak if it's strictly greater than the both of the immediate neighbors, right? And it is strictly less than both immediate neighbors. It means it's a valley, correct? Means we already talked about what is valley and what is the peak. This is called valley and this is called peak, right? So if neighbor we have smaller and the like in this case, so this creates a peak, right? So this is called peak. Okay. I hope you already gone through the first part of the video, so you'll already understand. Then we have the first and the last digit of the number that cannot be peak or valley. Means if we'll take the first digit and the last digit, here there is no neighbor from this side and no neighbor from this side. It means we will not count at this place any peak or valley. So any number with fewer than 3 digits has a waviness, right? And which is 0, we can say that. So total sum we have, what we have to return is the total sum of waviness for all the numbers in the given range. Means let's suppose we'll talk about 20 to 30. Means basically not 20 to 30, 201 to 300, let's suppose we'll talk about, right? So what is the, all those numbers have the waviness that we will do the sum and will return it. This is the problem statement says that. You can go through these examples so you will clearly understand, guys. Okay, let's talk about little ahead about this problem so you will understand. Okay, and this is the constant we have. Basically the constant defines this is the different problems. Okay, so the very first thing what you should understand is the lead code problem 3753 is it's about the total waviness of the number in the range 2. Basically this problem asks the sum of the waviness for every number between the nums1 and nums2, right, in the inclusive range. Okay, now it is saying that a digit is a peak if it is strictly greater than the neighbors, and it's a valley if it is smaller than both neighbors. The first and the last digit never counts. It means any number with fewer than 3 digits having waviness is 0. Means if less than 3 means 48 we have, there is two digits are there, means its waviness at both places will be 0. Okay, so the constant goes up to 10 to the power 15, as you can see here, right? It goes to 10 to the power 15, right? It means what? That the constant will define, and it give you the hint that we need to use a digit dp, and we will use the dps states like position, tight, last digit, second digit, that we will talk more in the details. Like that, it gives you the suggestion that you should use it and you should implement in the dp solutions. The very first thing you should understand is a good way to think about it is like every time you place a new digit, right, the middle of the last three digits become decided. Let's suppose what is trying to say that, let's suppose we have 48. So as soon as you will put this value right here, any value, that value will decided for this value, right, the middle element, the what the outcomes will come for this one, right? For example, let's suppose we have 4848, right? Two times we have 48. So let's talk about the 8 here, right? If you talk about this 8 and 8, right? So here 8 is bigger than this 4 and this 4, right? Means for this case I'm talking about. When we talk about this 4, right, means it is smaller than these two, right? Means if this is smaller, right, means it will go for this one. So if you'll talk about this 4, right, at 4 it is gives you the value, but these two 4, right, if you see this one, this is 8. For this 8 is bigger, means this is a peak, we can say that, correct? Means 8 is bigger than both 4 this 4 and this 4. So that is why we talked about this one. So 484 has waviness of 2, which matches the sample of the given problem that we have already talked about, right? Let's talk about the idea. Basically, we should compute the formula. Let's suppose you have given the nums2 and then what we have in the nums1. So nums1 minus 1 we will go, and the given function we have f nums at 2. So you will get some values, right? So you'll get, once you'll get these values here and here, right, definitely you do the minus and you will get the answer, right? But what is the function at x? Basically the function at this value that we are using is the total waviness of all numbers that start from 0 to x. Let's suppose, means if we have to find from 200 to 300, let's talk about like this. Okay, if we have given these two digits, means this is nums1 and this is nums2. So let's suppose if we will find from for 300, right, let's there's a function at 3, means 0 to 300, if we will find 0 to 300 all the waviness, right, and if we'll find for this one, means 199, means 0 to 199. Obviously if you'll do this minus this, you will get the correct answer from 200 to 300 between all of them, right? So you will compute this way, and this way you will find the value. So this is the things we have, but you are calculating overall, right? That concept is called the we basically will use the dp, right, dp digits, and we will calculate it. So to calculate that of this function f of x, right, we will use the dp and digit dp, we can say that, and we'll pass some parameters. These are the parameters that we are going to use. Basically we have post, means the position which the digits are going to fill, right? Then we have tight, right, where we are still limiting by the x, right? And the started we have whether we have placed the first non-digit yet or not, and then we have previous one and previous two, means the last two digits. Let's suppose we will talk about the 48. So for in this case this is previous one, but when we talk about the previous two, means when this have to move, means this become previous one, this become previous two. If any other elements will come 484, now it is previous one, this is previous two, right? Like that it will come, the new digit will come, we have to roll like that. So this is called previous one, previous two. We'll talk about more in this one, don't worry. Let's talk about the states. Let's understand the state. Suppose currently we are building 48. Okay, 48 means what? The how we'll store the states, right? The previous two is called 4 and previous one is called 8, right? That we already knows, previous one, previous two, right? Let's try some digits. So basically we want to add a new digit, let's call 4. So case 1 we have where we are adding the 4, means at this place you will add some value, so it become what? 484, correct? So now we'll check the middle element. What is that middle element? Is 8. So 8 is greater than this 4 and this 4, means this is called peak. Okay, and the peak will contribute +1 in the waviness, so you can add that +1 in the waviness. Let's move to the window. Okay, when we want to move to the we want to move the windows, right? So we'll talk about some new elements, right? So we move the window from here. Basically previously window was here, right? Now we have moved the window here, correct? So previous we have got changed. Let's suppose the next 8 4, right? We will add that we have seen that we have added the 4. Now at this position we'll add 7. Let's talk this one. Similarly we'll check the element, it's also greater than this and this, so it also gives you the peak, so you will add the +1 in the waviness. The same thing, you can move the again the windows and you will update this one. So like this it will keep going, and this is called the sliding window. Basically in the entire idea we will use the sliding window for the this previous one and previous two, so you will keep updating your result. So why we'll store the last 2 digits? Basically because we, whenever the new digits arrive, let's suppose in this case we have ABC, right? So we need to know, what we need to know is if B is greater than A, means this B is greater than this A. Let's come now. So if this B is greater than this A and B, it means this is a peak, right? If this B is less than this A and this B, means it will give you the value, right? So we should know about these things, that how come we, this last 2 digit will help you, right? So we should store that. How, what we will do that basically? So we have, so as states we must remember is the last 2 digit, because we have previous one, let's call B and A, right? We have A, B and C in this case, right? So let's suppose if we know the previous B and A, right? So when C arrives, right, like A, B we have, right? So this is your previous 2 and this is previous one. So whenever A, B and C, the next digit will come, right, will arrive, the next digit, then it will decide again, right? Means we, how we will evaluate the B here when the new digit will come. Let's suppose B, A and B was there, so this is previous one, previous 2. Whenever the new digits come here, right, means how will evaluate these digits, right? That's all we can say, that we can evaluate B if the new digits arrive, right? And so that we need to understand what is at previous 2 and previous 1. Let's talk about the DPS states. So DPS states is DP, where we'll use the pause, tight, started, previous 1, previous 2. So this position is the, currently we are filling at this position. This is tight, means still matching the upper bounds. Then we have the started, means non-leading digits started, and then you know the previous 1, previous 2. So let's go through the example to understand how we are understanding the DP here. So suppose we have upper bound. Let's suppose we have 484 we have, right? So we started, so it is blind because we have started just. So in state we have the pause is equal to 0, right? Then we'll use the very first is 4, means we will keep in the state the previous is 4. Now we'll move to next, means the previous will get updated. So whenever we'll reach, we'll choose the 8, right? So for this we don't have anything, but for this we have 2 previous, this 2 3, right? So at 2 will pass the 4, at 1 will pass the 8, right? So this is the way we maintain the states. Okay, still we don't have the waviness because we have just 2 elements we have, right? We need the 3 digits, so we'll choose this digit also. So when you choose this digit, right, we will have what, 484, means basically now you have F1 and F2 with the third digits. So whenever you need the three digits, right, means you are complete, right? Means you can apply the formula. Which formula? Means basically we will check the middle. So what is the middle? Middle is 8. So middle will check greater than, it is greater than this one and this one, right? Means if it is greater than, it will give you the peak, means we will count +1 in the waviness. Okay, so the state becomes what now is, we are maintaining these and these 2 states we are maintaining here, so we will maintain it. Okay, now the finish started, means the total waviness will generate, and we'll say okay, this is the total waviness. Let's talk about the magical part, that is very important here. Okay, so not here. What is the magical part in here? Magical part is, it is very important to understand, like suppose we have reached 48. Okay, and give me a second. So we suppose we reach to 48, right? And there are 1000 ways to complete the remaining digits, right? It means if any other digit we have here, means there is multiple ways to count, right? So this digits makes 8 a peak. If this digits comes, it can make this digit 8 as a peak. Then every completion contributes plus 1. Let's suppose this digits is anything. It can be many ways we can create here, right? So this digit goes to, let's suppose, from where 0 to 7, it will keep going. Means for every case we'll do the plus 1, and so it will keep updating the value. Okay, so basically when the 8 will come, when this digit will come, right, basically it gives you the 8 to make the peak, right? So whenever the peak will happens, it will come, it will give you a contribution plus 1 in the where in the waviness, right? So what will happen, that contribution goes to 1 into number of suffixes. What are the number of suffixes are there, that you will keep multiplying, that will give the contributions. That's why we use the dp stores, and we will find like ways and waviness sum. We'll keep storing that, and we will maintain the dp stores. Let's talk about the code so you can understand easily, guys. Not, I'm not wasting your time. So let's think about here. Okay, the solution what we have is basically we'll maintain, right, the sentinel. We can say that if no digits are there, right? So let's call digits we have, ways memo we have, some memos we have, and the scene we have. So these things you have to maintain, right? So let's suppose that we have nums1, nums2 we have. So basically you create a function solve that we already seen in the previous lecture, right? We understand the basic version of this problem, right? Where we understand that solve function will give you the waviness, it is peak or not, right? Like that. So basically when you pass this nums1 and nums2, you know already why we are doing that, nums2 minus nums1 minus 1, right? So it will give you the answer, right? And this answer we are resulting, but the main function is that the total, right? How we'll find the total waviness here, right, for this nums2. So we'll create a function, right, well, that it will take a number x. Let's suppose very first you will check if number is less than x, will return 0. Otherwise what we will do, guys, otherwise what we will do, we'll convert into the 2-char array, right? We'll call this as a digits, right? We'll go on the digits, we'll keep all these digits, right? And we'll maintain it s at I, as this is called digits, means basically we are initializing this value, right? Let's talk about the how we are going to update it. Okay, so very first let's n equal to digits dot length. You will know how many digits you have, then you can maintain your, you can initialize your base memo, sun memo, and the scene you will maintain like this. Okay, let's talk about when we will start the dfs. So basically we will start from the position 0, then we from where we will started, right? And the cent will pass, right? So you will say the previous and the previous one, right? Sorry, previous two and previous one, will say like that you will pass. Okay, so you can see here, right, the position will pass, started will pass, previous two, previous one, and the type we have, like that we will keep passing all those value. I think it's cut. Okay, like that you will pass. Okay, then you will check that if it is already seen, you return do not calculate. Otherwise check this position, if it reached to the last position, means we will update everything like this, and will mark is, we will return the true. Otherwise we have to calculate. How will calculate that? If type is equal to 1, digit at position is 0, right, we'll update our total base and total sum. Now we'll go for all the digits, means from 0 to the limit, right? And then we'll find the next type. How will find that? You will check the type is equal to 1 or d equal to the position, right, like that. And if 1 is equal to 0, not is equal to, means if matching these conditions, right, if it is true, these two conditions, it will goes to 1, otherwise 0, means 0 or 1 will happen. Then you will say the next started, right, and what is the previous to previous one, and add is 0. Okay, so the very first thing is you check if start is 0, then still leading 0, means you will check. Otherwise you update the start is 1, sent updated, and 2, like this will say. But here the sent will update it because it's leading 0. Okay, like that we can say that. Next, we'll check the previous is sent, means we have exactly one real digit so far. So we'll update the value like this. Basically, started is equal to 1, the previous will update as stated 1, and the previous goes to the new digits. Okay, like that we will keep, means we already talked about these cases, guys. Now the next cases is now the middle digits previous can be judged or not. So you will use this for the peak or not, right? If it is peak or if it's a value, then in this case you will just say add equal to +1, right? And we'll keep updating the value like this. You will maintain again, and in the next DFS internally you'll call that, because this is recursive way, so you will update this value, the recursive call you will call, and will maintain this value. Okay, pause +1 you will do. Next started, from the started to next started will go, next previous one will go, and the next type like this will go. Okay, then we will maintain our child base and child sum will do. And in this way you just once you find the child base, you will update the total base, and similarly you will update the total sum like this. So basically +1 you will do child sum, you will multiply, add into the child base, and you will keep updating your total sum. And then these are the things that you need to maintain: the base memo and the sum memo and the scene will maintain all these three. So like this, it's little tight code, right? Let me know in the comment section. I can put the code into the comment section and you can do the debugging. So basically it will help you. The most important thing is you need to understand is what are the things is required, right? How will get the solution, right? And how will you perform the logic here, right? This is what we have, and I try to cover in very short time so you can understand easily. Okay, and if any doubt you have, let me know in the comment section and we can discuss there. Thank you so much, and do debugging, do some console messages, understand things so it will become a little clear to you. Okay, thank you for watching this video, and see you in the next one. And yeah, that's all I have with this video. I'll see you in the next one.